Max thinks he's a normal size. He's not. Max is floating exactly halfway between the smallest possible thing in the universe and the largest. Halfway between a length so tiny that physics itself stops working, and a structure so vast that light hasn't had time to cross it since the beginning of everything. And in the next 20 minutes, we're going to shrink him down to the bottom, then blow him back up to the top. From the floor of reality to the ceiling, both directions, full speed. Cosmo is coming too. He doesn't know what's about to happen. That's probably for the best. Fair warning, by the end of this video, you will feel very, very weird about your hands. Let's go. We start with Max, standing there, about 5'10" in his flight suit, average human, average height, completely unremarkable on a cosmic scale. Cosmo sits next to him, about 2 feet at the shoulder, also unremarkable, also completely unaware that he's about to become smaller than an atom. But here's something you've probably never thought about. Max is almost exactly in the middle, not the middle of space, the middle of scale. If you plot everything in the universe by size on a logarithmic chart, from the smallest measurable length to the diameter of the observable universe, humans land almost dead center. You are the universe's midpoint, the halfway house between infinity and zero. And that's either the most comforting or the most terrifying thing you've heard today, depending on your personality. Max finds it cool. Cosmo finds it irrelevant. He's licking his paw. Let's zoom out first. Then we'll go down. Step 1, Max's hand, about 7 inches across. He knows it well. He trusts it. It's made of cells, about 30 trillion of them in his whole body, actually. Each one a tiny, self-contained factory running chemical reactions that keep him alive. A single human cell is about 10 micrometers. That's 10 millionths of a meter. Already too small to see. You could fit 100 of them side by side across the period at the end of this sentence. Inside each cell, a nucleus. Inside the nucleus, chromosomes. Coiled up DNA containing 3.2 billion letters of genetic code. The instruction manual for building Max. Or building you, or building Cosmo. Cosmo's DNA is 84% identical to Max's, by the way, which explains a lot about both of them. If you stretched out all the DNA in one cell, it'd be about 6 feet long. If you stretched out all the DNA in Max's body, it would reach the sun and back over 600 times. He is literally made of a thread that could lasso the solar system. He just doesn't look like it because it's folded really, really neatly. Let's keep going down. This is where we start shrinking Max and Cosmo. Below the cell, below the DNA, we hit molecules. Water, proteins, fats. The building blocks of biology, a water molecule is about 2.75 angstroms, roughly 0.000000028 of a centimeter. At this scale, Max doesn't look like a person anymore. He looks like a vibrating cloud of shapes snapping together and drifting apart. Cosmo looks the same. At the molecular level, a man and his dog are basically the same thing, just atoms in slightly different arrangements. Below molecules, atoms. A hydrogen atom, the simplest, lightest atom in existence, is about 1/10,000,000th of a meter across. If you blew up an atom to the size of a football stadium, the nucleus would be a marble sitting on the 50-yard line. Everything else, empty space. Mostly nothing. The atom is 99.9999999999996% empty, which means Max is 99.9996% empty space. Cosmo is 99.996% empty space. The flight suit, the space helmet, the dog, treats in Max's pocket. All of it, almost entirely nothing. If you removed all the empty space from every atom in every person on Earth, the entire human race would fit into a volume smaller than a sugar cube. 7 billion people. One sugar cube. Cosmo tries to eat the sugar cube. Of course he does. All right, deeper inside the nucleus. This is where things start getting genuinely strange. The nucleus is made of protons and neutrons. These are about 1 femtometer across, a millionth of a billionth of a meter. We're now 100,000 times smaller than the atom itself. Max and Cosmo have been shrunk so far down that individual atoms look like solar systems above them. They're standing on a proton. It's bumpy down here. At this scale, the forces change completely. You've left the world of electromagnetism, the force that governs your daily life, that holds molecules together, that makes light, and entered the domain of the strong nuclear force. This is the most powerful force in nature. It's what keeps protons from flying apart, despite the fact that they're all positively charged and should repel each other like magnets flipped the wrong way. The strong force doesn't care about your feelings. It holds the nucleus together with a grip so tight that breaking it releases the energy of a nuclear bomb. That mushroom cloud? That's what happens when you mess with the strong force's stuff. Cosmo can feel the vibration. His ears perk up. He doesn't know he's standing on the thing that powers the sun. He just knows something is humming. Below protons and neutrons, quarks. These are fundamental particles, meaning they're not made of anything smaller as far as we know. There are 6 types, with names that sound like a physicist was naming cats. Up, down, charm, strange, top, and bottom. A proton is made of 2 up quarks and 1 down quark. That's it. 3 quarks, held together by the strong force, and that's the thing that makes up every atom, every molecule, every cell, every organ, every human, every golden retriever, every planet, every star in the universe. 3 quarks, all the way down. Cosmo spots a quark. Cosmo tries to eat the quark. The quark is a point particle with 0 physical size. Cosmo is confused. The quark is also confused. Nobody wins, but we're not done. Not even close. Below quarks, we enter a realm that's less physics and more philosophy with equations, because we're approaching the Planck length. The Planck length is 1.6 times 10 to the negative 35 meters. Let me try to give you a sense of how small that is, because your brain genuinely cannot process this number naturally. If you took a single atom, already inconceivably small, and blew it up to the size of the entire observable universe, a Planck length would still be smaller than a grain of sand in that universe. Let me say that again. Atom becomes the observable universe. Planck length is still too small to see. Max is staring into the void below him. There is nothing to see. Not because it's dark, because the concept of seeing has stopped being meaningful. Light itself is too clumsy to measure anything here. If you tried to look at the Planck scale with a photon precise enough to do the job, the energy required would collapse that photon into a tiny black hole. There are more Planck lengths inside 1 cubic meter of space than there are cubic meters in the entire observable universe. The bottom is further from us than the top. At this scale, our 2 greatest theories of physics, general relativity and quantum mechanics, crash into each other, and neither one survives. Space might not be smooth anymore. It might be foamy, turbulent, probabilistic. The very concept of distance might stop having meaning. This is the basement of reality, the floor beneath the floor, and the sign on the door says, "Current physics not valid beyond this point." Max looks down. There is no down. There is no where. There's just math that stopped working. Cosmo somehow is asleep. He curled up at the Planck scale and fell asleep. At the boundary where space-time dissolves into quantum foam, where the fabric of reality becomes uncertain and probabilistic, Cosmo found it comfortable. Golden retrievers will sleep anywhere. Max Planck proposed these units back in 1899, before quantum mechanics even existed. He wasn't trying to find the bottom of reality. He was trying to create a universal measurement system based purely on the constants of nature. But what he accidentally stumbled onto was a boundary, a wall, the point where the universe says, you can't go smaller, and if you try, I'll eat your equipment. Okay? Deep breath. We've hit the bottom. Now let's go back up. Past Max, past the planet, past everything, and zoom out. Max standing there, 5'10". Cosmo next to him. Let's pull back. His house, his block, his city. At about 10 miles, the curvature of the Earth starts to show. At 100 miles, you can see entire states. At 1,000 miles, you see the planet as astronauts see it, a blue marble hanging in nothing. Max has seen this view before from the cockpit. Cosmo pressed his nose against the window and fogged it up. Earth's diameter, about 7,900 miles. Sounds big until you compare it to Jupiter, which is 86,881 miles across. 11 Earths side by side. And Jupiter sounds big until you compare it to the Sun, 864,000 miles in diameter, or about 1.3 million Earths stuffed inside. But the Sun is average. It's a medium-sized star. There are stars so large they make the Sun look like a period at the end of a sentence. Scuti, one of the largest known stars, has a diameter about 1,700 times that of the Sun. If you placed it where the Sun is, its surface would extend past the orbit of Jupiter. You could fit almost 5 billion suns inside it. Cosmo's tennis ball is about 2.6 inches across. Scuti is about 1.5 billion miles across. If Cosmo's tennis ball were the Sun, Scuti would be a ball the size of a football field. Cosmo would still try to fetch it, and Scuti is just one star. In our galaxy, the Milky Way, there are between 100 and 400 billion stars, some bigger, some smaller, a cosmic city of nuclear furnaces stretching 100,000 light years across. 100,000 light years. That means light, moving at 186,000 miles per second, takes 100,000 years to cross our galaxy from one side to the other. And we've only been a species for 300,000 years. If you started shining a flashlight from one end of the galaxy the day Homo sapiens first walked upright, the beam still wouldn't have made it to the other side. But the Milky Way isn't alone. It's part of a group of about 54 galaxies called the Local Group. The Local Group is part of a larger structure called the Virgo Supercluster. The Virgo Supercluster is part of an even larger structure called Laniakea, our home supercluster, which contains about 100,000 galaxies spread across 500 million light years. Max is standing at the observation deck of his ship now, zoomed out so far that entire galaxies are dots. Cosmo is next to him, tail wagging slowly. Neither of them can process what they're seeing. Nobody can. The human brain didn't evolve to comprehend 500 million light years. It evolved to spot ripe fruit and avoid large cats. And yet, here's Max, trying. And Laniakea, it's one tiny node in the cosmic web, a vast network of galaxy clusters connected by filaments of dark matter and gas with enormous voids between them. The largest structures in the observable universe are these filaments. They stretch for billions of light years, like a cosmic spiderweb holding the entire universe together. And the observable universe itself, 93 billion light years across. Not because the universe is 93 billion years old, it's only 13.8 billion years old. But space itself has been expanding since the Big Bang, stretching the distances between galaxies like dots on an inflating balloon. So the most distant light we can see has been traveling for 13.8 billion years, but the object that emitted it has since been carried much further away by the expansion of space. And here's the truly humbling part. The observable universe is probably not the whole universe. It might be just a tiny bubble in something much, much larger, possibly infinite. We don't know. We might never know. The light from beyond our observable boundary hasn't had time to reach us yet. And if dark energy keeps accelerating the expansion, it never will. There are things in the universe that we will never, ever see. Not because our telescopes aren't good enough, because the universe is expanding faster than light can cross it. Some information is permanently locked away from us. The universe has secrets it's keeping forever. Cosmo whimpers softly, not because he understands, because Max stopped petting him 30 seconds ago, and that's unacceptable. So let's come back to Max and Cosmo. Max is standing roughly in the middle of all of this. Below him, quarks, Planck lengths, the quantum foam where reality stops making sense. Above him, superclusters, filaments, the cosmic web, the edge of the observable universe, and possibly infinity beyond that. Max is made of atoms that were forged inside stars that no longer exist. He is held together by a force so strong that breaking it powers nuclear weapons. He is 99.9999999999996% empty space that somehow has opinions about what to eat for lunch. And Cosmo? Cosmo is made of the same stuff, same quarks, same empty space, same atoms forged in the same long-gone stars. The only difference between Max and Cosmo, between a man and his dog, is the arrangement. A slightly different sequence of DNA, a slightly different folding pattern in the proteins. At the quark level, they're identical. At the cosmic level, they're both invisible. Max is a temporary arrangement of matter that learned to look in both directions, toward the impossibly small and the impossibly large, and somehow found himself right in the middle. Not at the top, not at the bottom, right in the center of the ruler, the universe's median, the exact midpoint between everything and nothing. And here's the wildest part. No one put him there on purpose. The laws of physics, the constants of nature, the scale of atoms relative to stars, none of it was designed with Max in mind. And yet, here he is, precisely sized to be too big for quantum mechanics and too small for cosmology. The universe's blind spot, the Goldilocks zone of scale. Max is not special because of his size. He's special because at his size, he can see in both directions. The very small and the very large are invisible to each other. But Max, at his scale, can hold a Planck length in one hand and the observable universe in the other, at least in his mind. No other scale can do that. No quark has ever contemplated a galaxy. No supercluster has ever wondered what it's made of. Only Max. Only you. Cosmo can't contemplate a galaxy, but he can contemplate Max. And right now, he's looking up at him with that golden retriever face. The one that says, I don't understand anything you just said, but I love you and I would like a treat. And honestly, that might be its own kind of understanding. So, how small are you? You are 1.6 times 10 to the 35 Planck lengths tall, and you live inside a universe that is about 8.8 times 10 to the 26 meters wide. You are a rounding error with a heartbeat, a speck that thinks, a collection of quarks that somehow became curious about quarks. Max looks at his hand, the same hand from the beginning of the video. It's still 7 inches across, still made of 99.9999999999996% nothing, still held together by forces that could level cities, still built from dead stars. He looks at Cosmo. Same atoms, same emptiness, same stardust, different shape, different job. Max scratches behind Cosmo's ears. Cosmo's tail wags, the same tail that wagged at the Planck scale, that wagged next to UY Scooty, that wagged at the edge of the observable universe. universe. The tail doesn't care about the scale. The tail just wags. And that is, without question, the most absurd and beautiful thing in all of physics. Next time, Max and Cosmo are ranking every black hole ever discovered by mass. Cosmo is going to try to fetch one. Max is going to have to explain why that's a bad idea. It's going to take a while.